The Buk Missile System (BK) is a family of self-propelled, medium-range surface-to-air missile systems developed by the Soviet Union and its successor state, the Russian Federation, and designed to fight cruise missiles, smart bombs, fixed and rotary-wing aircraft, and unmanned aerial vehicles. The Buk Missile System is the successor to the NIIP Vympel 2K12 Cub. The first version of Buk adopted into service carried the GRAU designation 9K37 and was identified in the West with the NATO reporting name Gadfly, as well as the U.S. Department of Defense designation SAR-11. With the integration of a new missile, the Buk-M1-2 and Buk-M2 systems also received a new NATO reporting name Grizzly and a new DoD designation, SAR-17. In 2013, the latest incarnation, Buk-M3, was scheduled for production. A naval version of the system, designed by NIIP Altair for the Russian Navy, according to Jane's Missiles and AMP rockets, received the GRAU designation 3S90M1 and will be identified with the NATO reporting name Golem and a DoD designation SAR-N7C. The naval system was scheduled for delivery in 2014. Development of the 9K37 Buk was started on the 17th of January 1972 at the request of the Central Committee of the CPSU. The development team comprised many of the same institutions that had developed the previous 2K12 Cub. These included the Tikhomirov Scientific Research Institute of Instrument Designers, the lead designer, and the Novator Design Bureau, which were responsible for the development of the missile armament. In addition to the land-based missile system, a similar system was to be produced for the naval forces, the result being the 3S90 Uragan, which also carries the SAR-N7 and Gadfly designations. The Buk missile system was designed to surpass the 2K12 Cub in all parameters, and its designers, including its chief designer Ardalian Rastov, visited Egypt in 1971 to see Cub in operation. Both the Cub and Buk used self-propelled launches developed by Ardalian Rastov. As a result of this visit, the developers came to the conclusion that each Buk transport-to-erector launcher should have its own fire control radar, rather than being reliant on one central radar for the whole system as in Cub. The result of this move from TEL to a transport-to-erector launcher and radar was a system able to shoot at multiple targets from multiple directions at the same time. During 1974, the developers determined that although the Buk missile system is the successor to the Cub missile system, both systems could share some interoperability. The result of this decision was the 9K37-1 Buk-M1 system. Interoperability between Buk-TELAR and Cub-TEL meant an increase in the number of fire control channels and available missiles for each system, as well as faster entry of Buk system components into service. The Buk-M1 was adopted into service in 1978 following completion of state trials, while the complete Buk missile system was accepted into service in 1980 after state trials took place between 1977 and 1979. The naval variant of the 9K37 Buk, the 3S90 Uragan, was developed by the Altair Design Bureau under the direction of Chief Designer G.N. Volgan. The 3S90 used the same 9M38 missile as the 9K37, though the launcher and associated guidance radars were exchanged for naval variants. After the 9S90 system was tested between 1974 and 1976 on the Kashin-class destroyer Provorny, it was accepted into service in 1983 on the Project 956 Sovereign many class destroyers. No sooner had the 9K-37 Buk entered service than the Central Committee of the CPSU authorized the development of a modernized 9K-37 which would become the 9K-37M1 Buk-M1, adopted into service in 1983. The modernization improved the performance of the system radars, its probability of kill and its resistance to electronic countermeasures. Additionally, a non-cooperative threat classification system was installed, relying on analysis of returned radar signals to purportedly identify and clearly distinguish civilian aircraft from potential military targets in the absence of IFF. Another modification to the Buk missile system was started in 1992, with work carried out between 1994 and 1997 to produce the 9K-37M1-2 Buk-M1-2, which entered service in 1998. This modification introduced a new missile, the 9M317, which offered greater kinematic performance over the previous 9M38, which could still be used by the Buk-M1-2. Such sharing of the missile type caused a transition to a different GRAU designation, 9K-317, which has been used independently for all later systems. The previous 9K-37 series name was also preserved for the complex, as was the Buk name. The new missile, as well as a variety of other modifications, allowed the system to shoot down ballistic missiles and surface targets, as well as enlarging the performance and engagement envelope for more traditional targets like aircraft and helicopters. The 9K-37M1-2 Buk-M1-2 also received a new NATO reporting name distinguishing it from previous generations of the Buk system. This new reporting name was the SAR-17 Grizzly. The export version of the 9K-37M1-2 system is called Ural. The introduction of the 9K-37M1-2 system for the land forces also marked the introduction of a new naval variant, the EZH, which carries the NATO reporting name SAR-N7B. Grizzly was exported under the name STIL and carries a NATO reporting name of SAR-N7C Golem. According to Jane's catalog, the 9K-317 incorporates the 9M317 missile to replace the 9M38 used by the previous system. A further development of the system was unveiled as a concept at EURONAVAL 2004, a vertical launch variant of the 9M317, the 9M317ME, which is expected to be exported under the name 3S90ESHTIL-1. Janes also reported that in the Russian forces it would have a name of 3S90M Smerch. The Buk-M1-2 modernization, based on a previous more advanced developmental system referred to as the 9K-317 Buk-M2, featured new missiles and a new third-generation phased array fire control radar allowing targeting of up to 4 targets while tracking a further 24. A new radar system with a fire control radar on a 24 meters extending boom reputedly enabled more accurate targeting of low-altitude planes. This new generation of Buk missile systems was stalled due to poor economic conditions after the fall of the Soviet Union. The system was presented as a static display at the 2007 Max Air Show. In October 2007, Russian General Nikolai Frolov, commander of the Russian Ground Forces Air Defense, declared that the army would receive the brand new Buk-M3 to replace the Buk-M1. He stipulated that the M3 would feature advanced electronic components and enter into service in 2009. The upgraded Buk-M3 TELAR will have a 7 rollers tracked chassis and 6 missiles in launch tubes. Description: a standard Buk battalion consists of a command vehicle, target acquisition radar vehicle, 6 transport-erector launcher and radar vehicles and 3 transport-erector launcher vehicles. A Buk Missile Battery consists of 2 TELAR and 1 TEL vehicle. The Buk-M1-2 TELAR uses the GM569 chassis designed and produced by JSCMMZ. TELAR superstructure is a turret containing the fire control radar at the front and a launcher with 4 ready-to-fire missiles on top. Each TELAR is operated by a crew of 4 and is equipped with chemical, biological, radiological, and nuclear protection. The radar fitted to each TELAR, referred to as the Fire Dome by NATO, is a monopulse-type radar and can begin tracking at the missile's maximum range and can track aircraft flying at between 15 meters and 22 kilometers altitudes. It can guide up to 3 missiles against a single target. The 9K-37 system supposedly has much better ECCM characteristics than the 3M9 Cub system that it replaces. While the early Buk added a radar tracking system 9SH38, its current design can be fitted with a combined optical tracking system with a thermal camera and a laser rangefinder for passive tracking of the target. The 9K-37 system can also utilize the same 1S91 straight flush 25 kW GH band continuous wave radar as the 3M9 Cub system. The 9S35 radar of the original Buk TELAR uses a mechanical scan of the Cassegrain antenna reflector, where the Buk-M2 TELAR design used a PESA for tracking and missile guidance. The 9K-37 utilizes the 9S18 tube arm, or 9S18M1 target acquisition radar in combination with the 9S35 and 9S35M1 Fire Dome HI band tracking and engagement radar, which is mounted on each TELAR. The Snowdrift target acquisition radar has a maximum detection range of 85 kilometers and can detect an aircraft flying at 100 meters from 35 kilometers away and even lower flying targets at ranges of around 10 to 20 kilometers. Snowdrift is mounted on a chassis similar to that of the TELAR, as is the command vehicle. The control post, which coordinates communications between the surveillance radar and the launchers, is able to communicate with up to 6 DELs at once. The tail reload vehicle for the Buk battery resembles the TELAR, but instead of a radar they have a crane for the loading of missiles. They are capable of launching missiles directly but require the cooperation of a Fire Dome-equipped TELAR for missile guidance. A reload vehicle can transfer its missiles to a TELAR in around 13 minutes and can reload itself from stores in around 15 minutes. Also, the Buk-M2 featured a new vehicle-like TELAR but with radar atop of a telescopic lift and without missiles, called a Target Acquisition Radar 9S36. This vehicle could be used together with 2 TEL's 9A316 to attack up to 4 targets. Missile guidance in forested or hilly regions. The mobile simulator SAM Buk-M2E was shown at MAX 2013. A self-propelled fire simulator installation JMA9A317ET SAM Buk-M2E, based on the mobile, is designed for training and evaluating the combat crew in the war environment to detect, capture, lock onto, and defeat targets. A computer information system fully records all actions of the crew to a black box to allow objective assessment of the consistency of the crew's actions and results. All vehicles of the Buk-M1 missile system use an Argon-15A computer, as does the Zaslon radar. It is produced at a Kishinev plant originally named 50 years of the USSR. The vehicles of Buk-M2 missile system use a slightly upgraded version of Argon-A15K. This processor is also used in such military systems as anti-submarine defense caution and SOVA airborne radars for MiG-31 and MiG-33. Mobile tactical missile systems Tochka, Oka and Volga. Currently, Argons are upgraded with the Bagat series of processes by NIIP. Basic missile system specifications: target acquisition range 140 km, altitude 60 meters 25 km. Firing groups in one division, up to 6. Firing groups operating in a sector 90 degrees in azimuth, 0 to 7 degrees and 7 to 14 degrees in elevation, 45 degrees in azimuth, 14 to 52 degrees in elevation. Radar mast lifting height, 21 meters. Reloading of 4 missiles by tail from itself, around 15 minutes. Combat readiness time, no more than 5 minutes. Kill probability, 90 to 95%. Target engagement zone: aircraft altitude 15 meters 25 kilometers, range 3 to 42 kilometers. Tactical ballistic missiles: altitude 2.0 to 16 kilometers, range 3 to 20 kilometers. Sea targets up to 25 kilometers, land targets up to 15 kilometers. Chance to destroy aircraft 0, 7 to 0, 93. Maneuvering the aircraft 0.6. In 92, the system has proven the ability to destroy Scud missile R-17 and rocket MLRS caliber of 0.3 meters. Operation: the Buk is a mobile, radar-guided surface-to-air missile system with all 4 main components: acquisition and targeting radars, a command element, missile launchers, and a logistics element mounted on tracked vehicles. This allows the system to move with other military forces and relocate to make it a more difficult target to find than a fixed SAM system. The acquisition radar component allows the system to identify, track and target selected targets. The command component is intended to discern friendly military aircraft from foes, prioritize multiple targets, and pass radar targeting information to the missile launch. The missile launcher component can carry a variety of missiles and may be able to engage more than one target simultaneously. The logistics component carries additional missiles and provides other supplies and parts for the system and the operators. In general, the system identifies potential targets, selects a particular target, fires a missile at the target, and resupplies the system. The missiles require a radar lock to initially steer the missile to the target until the missile's onboard radar system takes over to provide final course corrections. A proximity fuse aboard the missile determines when it will detonate, creating an expanding fragmentation pattern of missile components and warhead to intercept and destroy the target. A proximity fuse improves the probability of kill given the missile and target closure rates, which can be more than 3,000 km/h. Alternatively, the command component may be able to remotely detonate the missile, or the onboard contact fuse will cause the warhead to detonate. The most capable radar, assuming it has a line of sight, can track targets as low as 30 meters and as far as 140 kilometers. The most capable missile can hit targets as far as 50 kilometers and more than 24,000 meters in altitude. Since the introduction of the Buk in the 1970s, the capabilities of its system components have evolved, which has led to different nomenclature and nicknames for the components' variants. The Buk has also been adapted for use on naval vessels. Integration with higher-level command posts. The basic command post of the Buk missile system is 9-510, 9S470M1-2 and 9S470 vehicles, organizing the Buk system into a battery. It is capable of linking with various higher-level command posts. As an option, with the use of HLCP, the Buk missile system may be controlled by an upper-level command post system 9S52 Polyana D4, integrating it with S300V, S300VM into an air defense brigade. Also, it may be controlled by an upper-level command post system 73N6ME by Carl-1ME, together with 1 to 4 units of PPRU-M1, integrating it with SA-19 Grizzly into an air defense brigade, as well as SA-10 20ths and SA-5 Gammon and SA-2 Guideline and SA-3 GO, an air force. With the use of the Mobile Command Center Rangira-M, the Buk missile system allows creation of mixed groups of air defense forces, including TOR, Tunguska, SDRELA-10, and IGLA. SENES is another optional command post for a free mixing of any systems. In addition to mixing the potential, each of the air defense system with the aid of SENES can become part of another air defense system, and do not lose quality. The system works automatically, but for the full realization of all functions, a SENES control system need various other monitoring systems for air defense and air force. Otherwise, a SENES system will work as a command center, but not within a free association. 3S90 Uragan M22 to the 3S90 Uragan is the naval variant of the 9K-37 Buk, and has the NATO reporting name Gadfly and US.The designation SARN7. It also carries the designation M22. The export version of this system is known as STIL. The 938 missiles from the 9K-37 Buk are also used on the 3S90 Uragan. The launch system is different, with missiles being loaded vertically onto a single-arm trainable launcher. This launcher is replenished from an underdeck magazine with a 24-round capacity. Loading takes 12 seconds to accomplish. The Uragan utilizes the Mr. 750 Tops Tier D E-band as a target acquisition radar, which has a maximum detection range of 300 kilometers depending on the variant. The radar performing the role of the 9S35, the 3R90 front dome HI-band tracking and engagement radar with a maximum range of 30 kilometers. Operation 1974 has been tested on the new ship in 1980. It was adopted in 1983. 3S90EZH, the modernized version of the 3S90 meters, is the 9K-37M1-2 EZH, which carries the NATO reporting name Grizzly, or SARN12, and the export designation STIL. It uses the new 9M317 missile. In 1997, India signed a contract for the 3 Project 1135.6 frigates with STIL. Later, when the decision was made to modernize it with a new package of hardware and AMP missiles, the name changed to SHTIL-1. 3S90M SHTIL-1. In 2004, the first demonstration module of the new 9M317ME missile was presented by Dolgoprodny Scientific and Production Plant for the upgraded 3S90M SHTIL-1 naval missile system, designed primarily for the export purpose. Its latest variant used a vertical launch missile which is fired from underdeck silos clustered into groups of 12, 24 or 36. The first SHTIL-1 systems were installed into ships exported to India and China. Old systems Uragan, EZH and STIL could be upgraded to SHTIL-1 by replacing the launcher module inside the ship. The reaction time is 5 to 10 seconds. The interval between starts is less 2 seconds. To protect against birds, helicopters, aircraft, anti-ship missiles. 938 and 938M1 missile. The 9M38 uses a single-stage 10-wing design without any detachable parts. Its exterior design is similar to the American Tartar and Standard surface-to-air missile series, which led to the half-serious nickname of Standardsky. The design had to conform to strict naval dimension limitations, allowing the missile to be adapted for the M22 SAM system in the Soviet Navy. Each missile is 5.55 meters long, weighs 690 kilograms and carries a relatively large 70 kilograms warhead which is triggered by a radar proximity fuse. In the forward compartment of the missile, a semi-active homing radar head, autopilot equipment, power source and warhead are located. The homing method chosen was proportional navigation. Some elements of the missile were compatible with the Cubs 3M9, for example, its forward compartment diameter, which was less than the rear compartment diameter. The 9M38 surface-to-air missile utilizes a two-mode solid-fuel rocket engine with total burn time of about 15 seconds. The combustion chamber is reinforced by metal, for the purpose of reducing the centering dispersion while in flight. The combustion chamber is located close to the center of the missile and includes a longer gas pipe. The 9M38 is capable of readiness without inspection for at least 10 years of service. The missile is delivered to the Army in the 9YAR 266 transport container. The 938M1 missile uses active homing when approaching the goal. 9M317 missile. The 9M317 missile was developed as a common missile for the Russian ground forces, air defense forces as well as for ship-based PVO of the Russian Navy. Its exterior design bears a resemblance to the Vympel R-37 air-to-air missile. The unified multifunctional 9M317 can be used to engage aerodynamic, ballistic, above-water and radio contrast targets from both land and sea. Examples of targets include tactical ballistic missiles, strategic cruise missiles, anti-ship missiles, tactical, strategic and army aircraft and helicopters. It was designed by OJSC Dolgoprudny Scientific Production Plant. The maximum engageable target speed was 1,200 meters per second and it can tolerate an acceleration overload of 24 g. It was first used with Buk-M1-2 system of the land forces and the SHTIL-1 system of the naval forces. In comparison with 9M38M1, the 9M317 has a larger defeat area, which is up to 45 kilometers of range and 25 kilometers of altitude and of lateral parameter, and a larger target classification. Externally, the 9M317 differs from the 9M38M1 by a smaller wing chord. It uses the inertial correction control system with semi-active radar homing, utilizing the proportional navigation targeting method. The semi-active missile homing radar head as well as 9E50M1 for the 9M38M1 missile and 1SB4 for Buk missile was designed by NIIP and manufactured by MMZ-Ola. The 9M317 missile uses active homing when approaching the goal. 9M317M and 9M317A missile development projects. Currently, several modernized versions are in development, including the 9M317M, 9M317ME, and active radar homing missile 9M317S, 9M317MA. The lead developer, NIIP, reported the testing of the 9M317A missile within Buk-M1-2 and OKRVSKHOD in 2005. The range is reported as being up to 50 kilometers, maximum altitude around 25 kilometers and maximum target speed around Mach 4. The weight of the missile has increased slightly to 720 kilograms. The missile's VSKHOD development program for the Buk-M1-2 was completed in 2011. This missile could increase the survival capability and firing performance of the Buk-M1-2 using its ability to hit targets over the horizon. In 2011, Dolgoprudny NPP completed preliminary trials of the new autonomous target missile system OKRPENSNE developed from earlier missiles. 9M317ME missile. The weight of the missile is 581 kilograms, including the 62 kilograms blast fragmentation warhead initiated by a dual-mode radar proximity fuse. Dimensions of the hull are 5.18 meters length, 0.36 meters maximum diameter. Range is 2.5 to 32 kilometers in a 3S9 NOM SHTIL-1 naval missile system. Altitude of targets from 15 meters up to 15 kilometers. 9M317ME missiles can be fired at 2-second intervals, while its reaction time is up to 10s. The missile was designed to be single-staged, inertial guidance, radio control mid-course update and terminal semi-active radar homing. The tail surfaces have a span of 0.82 meters when deployed after the missile leaves the launch container by a spring mechanism. 4 gas control vanes operating in the motor air flux turn the missile towards the required direction of flight. After the turnover maneuver, they are no longer used and subsequent flight controlled via moving tail surfaces. A dual-mode solid propellant rocket motor provides the missile with a maximum speed of Mach 4.5. Comparison. Other variants. Original design tree 9K37-1. Buk-1. First Buk Missile System variant accepted into service, incorporating a 9A38 TELAR within a 2K12M3 Buk-M3 battery. 9A37 Buk. The completed Buk Missile System with all new system components, back compatible with 2K12 Cub. 9K37M1 Buk-M1, an improved variant of the original 9K37 which entered into service with the then Soviet Armed Forces. 9K37M1-2 Buk-M1-2, an improved variant of the 9K37M1 Buk-M1 which entered into service with the Russian Armed Forces. 9K317 Ural. Initial design of Buk-M2 which entered into service with the Russian Armed Forces. 9K317E Buk-M2E. Revised design for export markets. 9K37M1-2 Buk-M1-2 redesign of Buk-M1-2 for the use of 9M317A missile. Buk-M2EK, a wheeled variant of Buk-M2 on MZKT-6922 chassis exported to Venezuela and Syria. 9K317M Buk-M3 in Russia. Some active work is being conducted, aimed at the new perspective complex of Buk-M3. The Zenith rocket division of it will have 36 target channels in total. Naval version design Tree 3S90M22 Uragan naval version of the 9K-37 Buk Missile System with 9M38 9th M38M1 missile. 3S90EZH naval version of the 9K-37M1-2 with 9M317 missile. 3S90 still naval export version of the 9K-37M1-2 with 9M317E missile. 3S90ESHTIL-1 naval export version with 9M317ME missile. 3S90M Smerch possible naval version with 9M317M missile. Copies Belarus. In May on the MALEX-2005 exposition in Minsk, Belarus presented their own modification of 9K-37 Buk, called Buk-M1. On the 26th of June 2013, an exported version of Buk-M1 was displayed on a military parade in Baku. It included the new NATO K6M Ukrainian-built radar on an MZKT chassis and the new Russian-built missile 9M317. People's Republic of China HQ-16 People's Republic of China project based on the naval 9K-37M1-2 system. Still, other sources also rumored the project involved some Buk technology. It is able to engage high-altitude and very low-flying targets. The most visual distinction between SAR-17 and HQ-16 is that the latter is truck-based and vertically launched instead of track-based SAR-17. Its total number of missiles increased to 6 from the original 4 in SAR-17 system. People's Republic of China HQ-16A improvement of the HQ-16 was redesigned control surfaces incorporating leading edge, thus has better performance at higher angle of attack than HQ-16. People's Republic of China HQ-16B further improvement of HQ-16A. People's Republic of China Li-80 export version of HQ-16A incorporating cold vertical launch method. Iran RAAD medium-ranged surface-to-air missile system using TAR-2 missiles. It has very similar layout to wheeled Buk-M2 EK9M317. It was shown during 2012 military parade.